I'm Sophie. Today we are going to solve a question under Chapter 1, Method. This question for KMS set to 2022 and 2023. So let's look at the question. Number 1A. Mass spectrum of copper is shown in figure. At the left we have relative intensity, and at the right bottom we have isotopic mass for copper. So in this mass spectrum, there are 69 of copper have mass of 16.3 EMU, and 31 of copper have mass of 65 EMU. Based on figure, write all the isotope of copper. From the mass spectrum, there are two isotopic mass for copper, which means there are two isotopes for copper. So we write the symbol of copper, then write their isotopic mass as their nuclear number. That's it. We move to the next question. Determine the percentage abundance of each isotope. To find percentage abundance, value of relative intensity divided with total of relative intensity times with 100, then we can get percentage abundance for each isotope. Easy, right? So question 3 wants us to calculate the relative atomic mass of copper. First, we need to find average atomic mass of copper by using this formula. Average atomic mass equals Km over K. Q stands for relative intensity and M stands for atomic mass. To substitute all the value in our calculation, then we will get 63.62 AMU. So to find relative atomic mass, 63.62 AMU need to be divided by 1 per 12 times with 12 EMU. Then the answer is 63.62. Okay, let's look at question B. Oxalic acid is used to remove the blood stain and rust. The composition of oxalic acid is 2.24% hydrogen, 26.65% carbon, and 71.08% oxygen by mass. The molar mass of oxalic acid is 90 grams per mole. 1. Determine the empirical formula for oxalic acid and the molecular formula for this compound. So, we assume mass of oxalic acid is 100 grams, then we need to form a table. The first row for element, carbon, hydrogen, and oxygen. Then percentage for each element automatically become their mass. After that, we need to find mole for each element. For carbon, we divide with 12, hydrogen we divide with 1, and oxygen we divide with 16. Lastly, for simplest ratio, for each number of mole, we need to divide by element that have smallest number of mole. Here, element that have smaller number of mole is carbon. Then we get 1 for carbon, 1 for hydrogen, and 2 for oxygen. So the empirical formula is CHO2. To find molecular formula, CHO2 times with N equals to molar mass of oxalic acid, which is 90. Then we substitute with molar mass of CHO2. After that, we will get value of N equals to 2. So CHO2 times with 2, then molecular formula for oxalic acid is C2H2O4. We move to the next question. Number 2. A solution of oxalic acid is prepared by dissolving 10 grams oxalic acid into water to produce 500 ml solution with density of 1.05 gram per ml. Calculate the concentration of the oxalic acid solution in terms of molarity and molarity. First, we need to find number of mole oxalic acid. So number of mole oxalic acid equals to mass of oxalic acid divided with molar mass of oxalic acid. Then we will get 0.1111 mole. After that, to calculate molarity, molarity of oxalic acid equals to number of mole oxalic acid then divide with volume of oxalic acid in liter. Then the answer is 0.22 mole per liter, or the unit is capital M. Okay, to find molarity, we need to find mass of oxalic acid by using formula of density of oxalic acid solution equals to mass of oxalic acid divided by volume of oxalic acid. Then we will get 525 grams of oxalic acid solution. Next, to find mass solution, mass of oxalic acid solution minus with mass of oxalic acid. So 525 minus 10, then we get 515 grams for mass of solvent. Finally, we can calculate the molarity of oxalic acid. Number of mole of oxalic acid divided by mass of solvent in kg. Then the molarity of oxalic acid is 0.23 mole per kg, or the unit is small letter m. The last question, C. Combustion of potassium chloride, KCl produce potassium chlorate, KClO3. According to the equation, 2 KCl reacts with 3 O2, produce 2 KClO3. Calculate the mass of oxygen gas required to produce 3.8 gram potassium chlorate with a percentage yield of 86%. To answer this question, we need to use formula of percentage yield of KClO3 equals to actual yield KClO3 divided by theoretical yield KClO3 times 300. Then we get 4.4186 grams for theoretical yield KClO3. Next, number of mole of KClO3 theoretical equals to mass of KClO3 divided with molar mass of KClO3. Then the answer is 0.0360 mole. By the equation, 2 mole of KClO3 equivalent with 3 mole of O2. Then 0.0360 mole of KClO3 equivalent with 0.0540 mole of O2. Then to calculate mass of O2 gas required is equals with number of mole of O2 times with molar mass of O2. Then the final answer is 1.728 gram. So our discussion ends here. I hope this video can help you guys to solve this type of question. Thank you for watching. Bye!